All right, let's start our second lecture on arithmetic sequence. And we're working on the next page out of our study guide intervention book. Again, use separate sheets of paper. Don't use the pages from your SGI book. So let's go ahead and get started. A quick review. A sequence is just a set of numbers that we call terms. They're in a specific order, and we say that they are separated by commas. Now, our numbers here, 6, 14, 22, 30, and 38, we will look at these and we can see that these each differ by a number 8. Because they all differ by the same constant number 8, we call this an arithmetic sequence. We also say that the number 8, the difference between the two numbers, is a common difference. So, we also said yesterday that the common difference could be positive or negative. We looked at this sequence and we can see that we can also have a negative 5 as our common difference. So, an arithmetic sequence is just a number pattern. We look for the pattern that increases or decreases at a constant rate, which we call the common difference. Today we're going to be studying a little bit about how can we use the sequence that we're looking at, the first term, the difference that they have, and how can we find any term in the sequence without having to go through the whole long list of numbers that would be in the sequence. So the first thing we did was we talked about subscripts, and we said that each term in the sequence would have a subscript. A sub 1 would be the first term, a sub 2 would be the second, and so on. We said that we are going to represent the common difference with the letter D. So, we're going to use the first term and the common difference in a formula that will find any term for us. This was the equation that we said. A sub n, remember, sub n just means that we're writing that little subscript n equals a sub 1 plus n minus 1 times d. Again, the sub n and the sub 1, those are just numbers to tell us a place in the list. They aren't used for math. It's not like we're going to add, subtract, multiply, divide. Nothing like that. It's just to hold a place in the list. So we didn't have to use variables A, B, C, D. So when we're asked to do this, we're going to be asked to find the nth term in an arithmetic sequence. So let's look at this example. A sub 1 equals 3, D equals 4, and n equals 8. So what does this mean? I'm asking you to find the 8th term of a sequence that starts at 3 and has a common difference of 4. So I could go ahead and say I know the sequence starts at 3. I could put, I know my common difference is 4, and then I could put 8 little blanks out here, or 7 little blanks, and go ahead and work my sequence out till I got to my 8th term. That wouldn't make much sense. I mean, you can do it, but it doesn't make a lot of sense because it's a lot of work that we don't have to go through. One of the things that I said was to remember that adding the same number over and over is called repeated addition, which is just another name for multiplication. So, let's do this the easy way by using the formula. We're going to take the same terms, or same variables, sorry. We're going to use the formula this time. A sub n equals a sub 1 plus n minus 1 times d. We're going to substitute. Anywhere we see an n, we're plugging in an 8. So a sub 8 equals Anywhere we see a sub 1, we're going to plug in a 3. Anywhere we see an n again, we're putting an 8. And anywhere we see a d, we're putting a 4. From this point, all we have to do is go ahead and simplify the equation. The left-hand side is simplified, much like we did with the function notation. The left-hand side doesn't have to be worked on at all. So let's concentrate on the right. The first thing we're going to do is go ahead and subtract 8 minus 1. Then we'll multiply 7 times 4. And finally we'll add 3 plus 28. So a sub 8 equals 31. If we were to go ahead and finish off our sequence and do it the long way, we would find just by adding 4 each time that we would get to 31. Let's look at two examples. Find the nth term of each arithmetic sequence, and we have two cases here. In the first one, we know the sequence starts at 8. We know that the common difference is to go down by 6, and we want the 14th term of the sequence. Once again, write your formula. Go ahead, anywhere you see n, you're going to plug a 14. Change a sub 1 to 8. N again becomes 14, and d becomes negative 6. Go ahead and work your math. Subtract 14 minus 1. Multiply 13 times negative 6. And then add 8 and negative 78. You'll get negative 70. So a sub 14, the 14th term of this sequence, is equal to negative 70. In the second example, we had a sub n equals a sub 1 plus the quantity n minus 1 times d. We have a sequence that starts at 12. It goes down by 5 on each term, and we want the 25th term. So substitute a sub 25 equals 12 plus the quantity of 25 minus 1 times negative 5. Go ahead and do your math. 25 minus 1, 24 times negative 5, and finally 12 plus negative 120. We get a sub 25 equals negative 108. We can use this formula to write the nth term of an arithmetic sequence, and then after that we can use that formula to find any term that we would like. So if we use this and we simplify it a little bit and rearrange things, we can use it to find any nth term. So for example, let's look at this equation. I said when we were working these to be very careful, because this is actually asking you to do two different things. You're asked to solve two problems. The first one is to find a general equation for the nth term of the sequence, and then after that to find the 20th term. So the first sentence is our first problem. We will start with finding the common difference. D in this case is 11. So we'll go ahead and remember that. Then we'll start with our formula. And this time we won't know n because we don't know that it's the 20th term yet. Remember, this is only the first sentence. So a sub n equals, we're going to put for a sub 1, the first term is 12. And for the difference is 11. At this point we can simplify this equation. It's simply use distributive property. So 12 plus 11 times n is 11n, and 11 times negative 1 is negative 11. So 12 minus 11 can be combined, and we're left with 11n plus 1. Remember that your variable term should always be in front of the constant. That's just good form. Now we've answered the first question. We have our equation for the nth term, and we can find any term that we want from this. the second question, or the second part of the problem, asks us to find the 20th term. So that means that n equals 20. Simply plug in 20, work the math, and get 221. The 20th term of this sequence is 221. Let's try that again. Look again, you'll see two sentences here, so that means we're working two separate problems or two separate parts of the problem. First thing we're going to have to do is find our common difference, which in this case is negative 10. The next thing we're going to want to do is use our equation, or our formula, sorry, to substitute in. A1 is 2, D is negative 10, and then we're going to follow the same procedure to multiply through for our distributive property. And we see that we have two double signs, which we are not allowed to have. That's not simplified until those are gone. So we'll take those out of there. And then we see that we have like terms with 2 and positive 10. So we'll put those two together and we're left with negative 10n plus 12. Our second part of the problem asks us to find the 15th term. So we just plug in 15 anywhere we see n, and we go ahead and solve it. We will get the 15th term is negative 138. So we did these 4 examples next, so let's go ahead and do those. In this first one, we find our common difference. We see that it's negative 13. We go ahead and we're looking for the general equation first. The general equation will be a sub n equals 3 plus the quantity n minus 1 times negative 13. We do our distributive property again, and we combine 3 and 13, which are our like terms. Then that's our general equation. Then we want to find the 15th term. Now we plug in 15 anywhere we see n, work the math, and find that the 15th term is negative 179. In example 4, we're going to write the equation the same way. So we look and our common difference is 9. We will use our formula. Our first term is 1, and our common difference we found was 9. We do our distributive property, and we combine 1 and negative 9 to get 9n minus 8. This is our general equation. You finished the first part. So let's go ahead and plug 12 in for n, work it out, and we get the 12th term of the sequence is 100. For example 5, we go ahead and we're going to do the nth term of the sequence, and we're going to try and find the 55th term. So we need to find our common difference, which was 8. Our first term is 2. We plug in 8 for D, do our distributive property, combine 2 and negative 8, and here is our general equation. At this point, we just need to substitute in 55. A sub 55 equals 8 times 55 minus 6. So 440 minus 6, or 434, is the 55th term. In example number 6, we're going to do the same thing. We're looking for the common difference, which is 8. We're going to plug in 10 for the first term, 8 for the common difference. We'll do our distributive property. You'll see we have 10 and negative 8 that we can combine, and so our general equation is 8n plus 2. We plug in the number 20 and multiply that out and add, and the 20th term is 162. So hopefully this has helped with how to work these problems. They aren't that difficult, but they do take a little time to get the procedure. Once you get the process and the procedure, these become pretty easy. So, hopefully you're able to do the homework with no problem, and we will see you tomorrow.